pick either kings, queens, or jacks. Well, we want to know, first of all, how many cards are kings, queens, and jacks?
12.
12. How many of those do you want? 12, choose 5. Okay, 12, choose 5. We get to 4 aces and another card. Hi guys!
Hi.
How are you?
Good, how are you?
I'm great. Did you want to play war real quick?
Oh, I'm a pro.
Ready? 1, 2, 3, win!
Murphy lost.
I won! Thank you. Have a great day.
You too.
Enjoy your weekend.
They're so long.
Did you know that person?
Not a clue.
Okay.
Do you think there's 2 here? Yes, you don't need it twice.
Oh, do I have to make a
Yes, you have to make up part. Genjo, make up part.
Alright, Mother Thunder.
Genjo will be here eventually. He's doing a French tour.
Yeah.
All right.
Because he's like
4 aces and 1 other card. Remember, you're looking at the number of occurrences that happens out of that 2-point-some-odd million card decks. Well, how many ways can you get all 4 aces? Well, you want the way to do that is you have to get one. You have to get all 4 of the aces.
I get it.
Wait, weren't you just other?
If you have 4 aces, how many of these do you want in this setup? 4 of them. So it's 4, choose 4. Now, how other many ways are there to get the other 48 cards? Well,
48.
here's a 7, there's 1, here's an 8, there's 2, here's a 2, there's 3, here's a 10, there's, and so on, and here's 48 more of them. 4, choose 4, 48, choose 1. And you want this occurrence to happen at the same time, so is it adding or multiplying? Multiplying. Does that make sense? A lot of people today, as I was doing problems like this, it's very helpful to see the card actually flip over. You visualize it a bit better. Now you want just 1 ace. If I want just 1 ace, I'm going to pick that out of how many aces? 4. All right, so if I take 4 aces, I'm going to pick 1.
So 4 choose 1.
Other way around.
4 choose 1.
How many other cards are left? How many of those do I want?
4.
So it's 4, choose 1, and 48, choose 4.
So,
Good for you, Bob.
so if you were given a specific card, say like the 5 of clubs, would you say 1 choose 1? Or,
No, we'll get into that later.
okay,
Because then you're talking even more specifically.
okay.
2 aces and 3 kings. 2 aces. Well, how many aces are there? How many do you want? 4, choose 2. As well as you want to get 3 kings. Well, how many kings are there? 4. How many do you want?
4 choose 3.
You multiply or add? Because you want their card at the same time. Very good. The last one. 4 of one kind, kings, queens, and so on, and then 1 of another kind. Now, in order to select the kind, you first of all have to pick a card. So we want to pick a card, any card, pick a card, any card.
8 cards.
I bet it's bigger than 2.
5.
He chose a 5. Now, what I want to think about is how many different different card values are there in a deck?
13.
There's 13 different cards. Do you agree? What we first had to figure out here was we had to pick 13, choose 1. We had to pick that I want to get all 5s. You okay with that? Of that all 5s, how many 5s do I want?
4 of them.
4 of them. So there are how many 5s in this deck? 4, right? How many of those do I want? And then how many cards are left? No. This is the one where we've taken 4 of a kind out. How many cards are left there?
448.
How many do we have to pick from? 1. Then it's a 48, choose 1. What happens here, I don't know if any of you guys looked at the solutions or anything like that. They don't normally throw this one in here because 4 choose 4 is what? 1. Who said that this morning? Who did that? Who it was? Anna Arnold. Anna Arnold brought it up this morning where she said that when you're looking at that, it makes more sense to think of, once you select, you say, I want to get all 5s, and then some other card. The first idea is I'm not picking it out of the deck. I'm selecting the card that I want to get all of. I'm looking to see, all right, how many times will all 5 show up with one other card? How many different ways would all 6s show up with one other card? Once you select the card that you're going for, 5, 3. Now, I want to get all 4 of them. So putting it in that 4 choose 4 is just kind of like a buffer saying, hey, that's the one you want to get all 4 of, even though the value itself is equal to 1. It's a nice clean buffer. Bonjour! Straight again!
Oh my god, that's very good now. Hey, where's Genjo? He's supposed to be eating.
That would be looking.
Wait, is that really?
Yes, it's real bread.
They were eating it.
Genjo ate it.
They don't
May-
actually bite it.
Miss Murphy, Genjo ate it, so you may want to see your glitter.
Can I ask just a great some?
Watch out for the bottom.
Is it a little bit because it's covered in powder?
I'll take the
Genjo got
Genjo.
blue powder. Take the Genjo. Hey,
Hey, Benjo! What's up, buddy? Buongiorno! I guess.
That's Italian.
Va bene, va bene.
Godfather now.
That's
right.
We're down. Pass it around.
99 pieces of bread on the wall.
It's pretty stale.
Oh, I'll cook bread.
Choose
Miss
one. I've
Murphy,
got
we use
that.
probability of bread. I'll eat the top.
Choose one because there's 13 pieces I wanted to go
Right.
Oh wait, the other girls
You're
also
picking-
are French.
There's only 13 different possible cards, and they picking that one.
Big long stage.
Now, how much did you pay?
From and cockroaches and all of the cockroach. It's long.
So you sent him a picture of you eating bread and Matt playing,
I will, but you already did it.
playing,
Yeah, take us
We should
Blackjack
have
yet?
given away the bread.
Oh, we should have given more bread.
What was one more was the bread?
Well, you did.
what do you want to look down here?
Bread. What?
Let me get Lincoln first, okay?
53.
Fish!
I'm just gonna take this last chunk.
So hopefully you guys noticed the fish list on the side there. Yeah.
Yeah, I did this time.
Good.
There's not like a link of anything now.
It's not time yet. From the list of different species of the fish shown, an aquarium enthusiast, otherwise known
What a
as
nerd.
a 5-year-old, a fish fanatic, a fish head. They're interested in knowing how compatible any group of 3 or more different species are. How many different combinations are there to consider? Now, 3 or more, which means you can look at 3 of them, or 4 of them, 5 of them, 6 of them, and so on.
Crap.
Each one of those events is independent of each other. You could have 3 fish in a tank, 4 fish, 5, so on. Red fish, blue fish, yellow fish, goldfish. How many fish are there? Very small aquarium. So you have 10 fish, choose 3, plus 10 fish, choose 4, plus all the way on to 10 fish, choose all 10. You want to see if the red platies is going to eat the Bala sharks, or the zebrafish are going to eat the tiger sharks, or the catfish is just going to eat everything. Red. That makes sense?
What's the answer to that?
Wait,
Oh, I got 9
10
PhD.
Can you have 10 choose 10 that you
Well, do we just count all that up?
Yep.
There was one like 54 where.
54 is the same idea. A concert series in the summer has 12 different performing artists. You decide to attend at least 4 of them. How many different combinations can you go to? So there's at least one, which means you can go to 4, 5, 6, 7, 8, 9, 10. It's the same problem then.
Or 12.
All the way up through 12. And you're adding them each time, because each one of those ideas is different. You could go to 4, you could go to 9, you could go to 10, you could go to 6, so on. Ms. Yeager.
49.
I just hear the crunch of bread.
I'm a sucker for bread.
Me too. Oh my gosh. switch all the
I actually kind of understood
You're going to go buy a car, yay! You have 7 color options. They normally don't mix colors because then you look silly. You want to pick one color of the car and then 2 options because that's all you can afford, which is cool. You're going to get power seats and, well, that's probably not even an option anymore. The tech option and the sunroof. Whatever. In this case, do you want these to be independent of each other, or do you want them to occur on the same car? So you're going to add and multiply. Multiply. So you have 7, choose 1, times 10, choose 2. Very good.
So guys, like it's like 2 colors on this car. Blue on one side, yellow on the other. Like just diamond sharp.
It's so
I've had this question come up quite often today, and the reason why most people don't catch it right off the bat because the wording is kind of weird, lack of better terms. There are 6 artists presenting 5 works of art in an art contest, none of which contestants is me. The 4 works...
Might be Genjo.
Could be Genjo, you're right. The 4 works judged best will be displayed in the local gallery. In how many ways can these 4 works be chosen from the same artist's collection? So basically, the first thing you want to identify is the artist. How many artists do you have to choose from? 6. So this becomes a 6. Choose one of them. Now, are these events independent, or are they dependent upon one another? They're dependent on one another, so you're going to multiply them out. Okay. Now, how many artworks are there? Each person. Excuse me, there's 5. And how many of them do they want to show? 4. There's your answer. Every time I look at your I think there's like a shade or something, like something like, I think there's like a dark cloud hanging on you. You all right? We good? Let's add to it tonight. Let's talk about binomial expansion real quick. Before everything gets bad and, you guys have to...
Time out. What was that like? What was that like? Let's do this. Day 2. Pascal's triangle.
Oh, that's great.
That's so depressing. You're like, you can buy Dale bread.
Dale bread.
It's really, their bread is really good.
ID's got great bread.
We do it all the time. We go to Jimmy John's. Joel Osco bread is pretty good.
Oh, yeah, you're right, yes. I like fresh bread, but I love the Italian bread. It's the bigger, a little bit fluffier.
Italian so soft.
I have to make sandwiches regularly with a big chunk of bread.
Sourdough bread is
All right, Pascal's triangle.
Sourdough bread is still
Last
very
year-
important topic.
At some point in time last year, you guys probably looked at something, if you guys had Pascal's triangle. At Pascal's triangle, you guys didn't look at the numerical value of it, but you kind of looked at the idea of the edges were always the same, and then the values interior were changing. What happens here is you're able to get consecutive value by taking the 2 numbers above to get the number below. So here, 1 plus nothing is 1, 1 plus nothing is 1, 1 plus nothing is 1. But what's 1 plus 1? What's 1 plus 2? What's 2 plus 1? What's 1 plus 3? Oh, sorry, put 1 here. What's 1 plus 3? What's 3 plus 3? And this pattern continues on and on and on. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. And so on. Yeah!
I like this.
This is Pascal's triangle. This is a occurrence that you can just draw things out. Yes, sir?
Wasn't it called like the Sierpinski's triangle?
That one's,
Oh, that was a different
Think
one.
it's
That
a-
was Sierpinski's where it's like the triangles that.
You have to use the
in the
midpoint.
intersection of the-
Yeah,
Triangle.
that's a different one, but this- oh, that's right, you guys did Sierpinski's. This one is just, this is using numerical. Well, what Pascal's triangle allows you to be able to do is that all of these numbers come from, you're right, good call, congratulations, you passed today.
Use fast.
But I still Use right. fail, I still fail in grammar.
Use right.
And I'm still ashamed of myself.
It comes from this. What's 0 choose 0?
One.
What's 1 choose 0?
1.
1 choose 1. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. It's so on. That's how this comes out of. These combination values are what create Pascal's triangle. Okay? What you can use these with is
Attention
to,
students and staff, this is a drill. A building emergency is currently now in effect. All staff and students must remain in their rooms until further notice. No one is allowed outside of the building. Semi-hauler truck has just slipped over on Dresser Road with hazardous material.
What's height? That looks
Teachers
so good.
will follow the protocol in the hazmat inside release. Custodians, please follow your hazmat guidelines.
are you cold?
Yes. It's all nice. Mr. Murphy.
Bread in that.
It's so dark in here. I can't stand it. Call the
There's
power.
no one outside the building, like the other building people on that are outside the building.
Yes. So what this allows you to be able to do is the following. You don't need to write it. I'm just showing you where this is all coming from. There's no need to write it because the pattern shows up in what's called the binomial expansion theorem. The binomial expansion theorem is a whole lot of mumbo jumbo. The binomial expansion theorem is this whole lot of mumbo jumbo for something that is extraordinarily simple. No, this is ridiculously easy. What's happened lately on ACTs, and I think even the park, they might give you a question. Well, they'll give you this weird polynomial and ask you what is the coefficient of the seventh term. What you're able to do with binomial expansion is by using these NCR values, you're able to find coefficients. You're also able to work with the exponent rules throughout the binomial. Let me show you this. When you have x plus 2 to the 4th power, and I'd ask you to FOIL that out. Yo, you can't come in here! It's dangerous! No! No, it's dangerous! Nobody go out in and out! AJ, are the windows closed?
The windows
No.
are closed, the blinds are.
Yeah, we're safe! So what happens here is that
He goes right back to it.
Why did they have to, why did they check when they can't even open?
I think she was joking.
Oh. She's not very funny. She's what gave me a turn. I'm fine. Was it Thomas? That was Elizabeth. I'm good. Don't even look at me, Molly. I can't
Again,
stand
at
it.
this point in time,
No.
you guys in the past would sit there and FOIL it out and multiply it out 4 times just to get all your stuff. 4th degree polynomial, it's not the end of the world, it's rather quick to do. When you start getting to something that's the 11th degree or 8th degree, you don't want to do that because that's a big pain in the tuchus. So let me show you how this works with a very nice using the NCRs. You can't take me seriously.
Because your vest is like all bent up. I know, it's twisted. And he's wearing like a long
Bonjour.
Now you look like a bus driver. I'm pretty sure my bus driver is what exact outfit.
You can't make light at the time of a drill. If you have a fourth degree polynomial, after you FOIL everything out, how many pieces will you have? How many terms separately will you have?
4.
5.
Remember, think about it. You've got a fourth degree, third degree, squared, first degree, and a constant. You will always have one more term than you do have degree. So what happens here is that you can use the binomial expansion, which is a whole bunch of this. We have 4, choose nothing, because that's where we're starting. First term is x to the highest degree you can. The second part is plus 2 to nothing. That's what the whole first term is. Just bear with me.
Bless you.
It's x to the fourth, 2 to the 0. The 4 choose 0 is the coefficient, some value. We know that's going to equal 1. The second term is 4 choose 1. It's going up 1. Now watch what happens with the degree of x. It goes down a degree, but the constant goes up 1 degree.
Oh, it's like that, when they foil out the cube things,
Yep.
they goes down as that one goes up. Is this like up off
It's
that?
the same thing. That's where it came from.
So now it's 4 choose 2x squared, y, 2 squared.
Perfect. The next value before, choose 2, x squared, 2 squared. What's the next one? X to the first, 2 cubed. 4 choose 4, x to the 0, 2 to the 4th. Now I've gone through all of them. You start at the highest degree, you work your way down. You start at the lowest degree, you work your way up. Same thing as that trinomial expand, we had a
That's
cubic.
that one.
It's the same thing, and it came from this.
Oh, that makes sense.
Okay?
How do we solve that?
How do you solve that? It's easy. What's 4 choose 0?
1.
1. What's 2 to the 0?
1.
What's 1 times 1?
1.
So your first term is x to the 4th.
Why can't they just say?
Oh, Lily, you're awesome. What's 4 choose 1? 4. What's 2 to the first? 2. So I'm going to write this out long form. It's going to be 4 times 2 x cubed plus 4 choose 2. Should be 6, I think.
I can't do French roses. What?
Remember, 4 choose 2 is 4, 3, 2, 1 over 2, 1, 2, 1.
Oh, you subtract them.
When you're doing combinations, you're subtracting the n and the r. So 4, 3, 2, 1 divided by 2, 1, 2, 1 would be 4, 3 divided by 2, which is 2 times 3, which is 6.
Fast.
Whoa. Slow.
4,
Okay, wait.
3, 2, 1 divided by 2 times 1, 2 times 1. Remember the rule, n factorial, n minus r factorial, r factorial. That's how you do n choose r. I'm shortcutting it. Okay. So this is 6. And like I said earlier, guys, after a few of doing these things, you're going to know what 4 choose 2 is from doing your homework. You're going to know it. But you have a button.
It's 6.
You have a button.
It's 6.
It'd be 6 times 4 x squared. 4 choose 3. Well, if I do 4 choose 3, it's going to be 1 factorial and a 3, 2, 1. So it just winds up being 1. Yeah, excuse me, 4. Then what's 2 cubed?
Attention students and staff, the drill is now complete. Congratulations and good job. You may now resume your normal school day.
Congratulations.
Wow.
Congratulations for what?
Thank goodness, this is making me sweat.
We did so good. We were so prepared. We had this flashlight out.
Were we awesome?
And you were wearing the vest.
In case you couldn't find me.
And the windows were closed.
The windows are closed.
Shut up, Thomas.
Thanks, AJ, for double checking. All right. Now, lastly, 4 choose 4 is what? 1. And then x to the 0 is?
1.
And what's 2 to the 4th? So if you expand this out, you wind up with x to the 4th, 8x cubed, 24x squared, 32x, 16. And you're done. Binomial expansion is a very, very rapid way to FOIL. Ridiculously easy to use.
That was cool how it turned out to be this.
11 choose 0, x is 11, so 0,
Yep, yep. But a lot of times if it's x to the 11th, they're just going to ask you what is the 9th term. You know, things like that. And you just have to figure out, well, if it's the 9th term, it's going to be 11 choose 9.
Wait a second.
X to the 2nd, y to the 9th. Because what happens here is I want you guys to see this. My first term, the last part's the 0, 0, 0. 1, 1, 2, 2, 3, 3, 4, 4. And always notice what's happening with your exponents. What's 4 plus 0?
4,
What's 3 plus 1?
4,
What's 2 plus 2?
4,
What's 1 plus 3?
4,
And 0 plus 4.
4.
Those values, if you get any of those values that don't equal each other out, you know you're screwing up somewhere. It's very self-checkable. Yes, sir?
If we're following a Common Core right now, we're supposed to be learning this the last month of the school year. Then why do they put that on the park, which is a month ago?
I don't know.
Because the park is not right.
I don't know. We're just getting there.
Just
We're learning. We're winging it.
I just don't want to park so
The park is designed to make the kids feel like crap.
Yeah, are you actually going to use it though, Thomas?
No, you won't. Forget it. I hate it. I'm getting a tattoo.
Tom's just gonna
When
get
I do
exploited.
that, I'm like, I'm out of that. Like,
Like, what would you do? What would you do if someone came in with a tattoo of all of the formulas
Oh, you
on
can
their
write
arm?
Thomas, you're showing them.
Oh, yeah. You can duct tape your
yeah,
arms.
why would you say that?
Or you'd have to wear sleeves. I think duct tape would probably be better because sleeves, you
You
could
just,
roll your sleeves.
Oh, I'm feeling
You can
hot
cut
here.
off.
I'm just gonna roll my
You
sleeves
just cut off
back.
the arm.
It's true. Hey, let's all sign AJ's cast and then we can give him all the
We
answers.
could write all the formulas on it.
What's that?
I'll spread the stuff on this.
Well, knowing your handwriting with your left hand, it's not going to help you. Or your right hand, sorry. I forgot. Questions?
No.
All right.
Wait, what was the other way to do
Did we
this?
just continue that?
That is the
on
other.
same page?
Oh, that is the other one?
No, waste more paper, maybe.
Yeah.
I know.
No, she said Kate, not Kate.
Just to show you, I'm not going to do this the whole way out because it's a pain. What did I change here?
Subtraction.
There's a coefficient as well as
Tracy.
subtraction. So what happens when we have to raise negative values to powers? What do?
You.
No. Put it in parentheses. So for example, if I have negative 3 squared, you should get positive 9, right?
Yeah.
But if it's negative 3 cubed, you'll get negative 27. Be careful. Whenever you raise a negative value to an odd exponent, it's always going to be negative. But yet, when you raise a negative exponent or negative value to a to an even value, it's going to be positive. Also,
will they give us negative exponents or?
no. The first part here is 2x. So when you write it out, it's going to be 2x to the 6th. Negative 3 to the 0.
Combination.
So you have to make sure you raise the coefficient also to the exponent. It's a very, very subtle mistake that people make. Okay? Very subtle. Just wanted to show you that. The math isn't hard. You've got a button to do all the combination things. Just watch your signs. It should alternate positive, negative, positive, negative.
So we put
6 to 0.
Yeah. Sorry, I was doing that correctly. But yes, that's what we would start with. So then your next one would be 6, choose 1, 2x to the 5th, negative 3 to the 1st, and so on. Okay? We all right on that? Okay.
When you write it out, I forgot, do you apply the,
Yes, sir. Yep, that's what I was trying to remind you guys of. So this would be 64x to the 6th. Yeah, but
What about that whole thing, because 6 plus 0 is 6, but then 6 plus 1 is not 5? 'Cause in the other, remember how we had the two things on the combination?
okay. You're looking at what's 5 plus 1?
Oh.
It's the first, it's the 6.
Oh, it's the
And then this one is, the one here will always match this. This here will always match that.
Oh, I got
So if
this
it's
one.
6, choose 4, the negative 3 will be to the 4th power. And then this one would have to be 2x squared, because these two have to add up to equal 6.
I got you, that makes
Okay.
sense.
It's very subtle. It's not like it's not scary. And if you have to the 6th power, you're going to have how many separate pieces? 7. Yay! All right.
Not playing war.
Not playing war.
Blackjack.
Okay. Val, since you. No.
What do you do that?
Val, I have a large number of homework problems and a small number of homework problems. So if you beat Clay has nowhere to go with this. So.
He plays very good.
Shut up, I hate you still.
Ooh, we're sitting on a 7.
Alright.
How do you see the cards?
Val, you might want to look at the other card first.
Yeah, that might help.
Yeah, hit me.
All right, so you either have 18 or an 8.
So we're gonna hopefully.
Go with the 8. Go with the 8.
True.
Does it really matter? We have an entire weekend to do the homework.
Okay, well, I can see.
Alright, let's go with the 8.
Why is she gambling for all of us?
Oh, man, 19.
Now, as of right now, you have a 19 or 9.
How do you play
I'm
blackjack?
gonna leave it at 19.
19.
How do you play blackjack?
So aces out right on top. So I need a 20 or 21 to give you more homework. Well, I have a 9. I need an ace.
Oh, I bet it's
We're not
on.
gonna do that.
Wait.
19, we push.
No! No!
Oh, let's play war.
Which means,
Val wins.
again,
Which means Val wins, right?
Man, I'm so
The younger person.
Double or nothing.
we're not double or nothing.
I know,
No,
I'm kidding.
Clay, no.
Thomas, you know, he would never double against a person like me. It's not like you can come up with double problems on the fly, what's your name?
Ready?
I have no worries. You can read up here.
9. This is a very, very nice.
You deserve that.
There's 19.
Yeah,
You get the fewer number.
How does this game work?
It's really simple.
According to my knowledge of playing Top Shotgun on Tinder,
Yeah, you did.
slapjack.
That was Jenna.
She's on a photography field trip.
That's all how it is.
Hey! B! C!
Do you want me to give her a
What
worksheet?
you got?
I can give her pictures of the
Okay.
worksheet.
Oh, God.
Right all over it. Give it to her on Monday morning. And say give it to you the day.
So that's right. So Val lost twice. You get more homework problems.
But I won twice.
You do it.
Did you win?
I don't know how that game works, so.
So we have a B. So you guys get the fewer amount. So it's 5 through 9, 14 through 17 on both sides. If you had to do the more problems, I was just going to give you like 3 extra on both sides. So you got one.
6 problems for all that stress, Mr. Murphy?
Yeah.
We could have had a heart attack and caused even more hazardous waste.
What?
It's a good thing we have a flashlight and our
safety
and we have a tarp. We have a tarp, so if we
Why do we have a tarp?
If you cause, well, you have a tarp.
Does it hurt me? You're not even like,
If I were to-
gambling or saying, we're literally gambling on.
If I were to,
No, we weren't gambling.
if I were to
There's no wagers placed. I wasn't taking any money from you. I wasn't taking anything back.
if I were to.
Well,
If I
we're
were to-
losing any money.
What if I don't go to this?
Hey, is anybody gonna see Olivia?
I'm going to see Jenna, so
Really?
I'll just send a picture.
Hey, Gabo, you have 6 minutes.
Exactly, we have 6
Let's play war.
Not right now, I have to save this.
Can I deal?
Honestly, I
Play a game.
forget.
Is it my favorite?